be covering today. Now, to begin with, we must understand what business process management means to each and every one of us. Whether we are a seasoned transformation professional, whether we are just starting off with our careers, we must try and understand what business process management means and how does artificial intelligence fit into the framework. Now, essentially, the key objectives of BPM are streamlining and standardization, enhanced productivity, and optimizing the quality of output. Those are the, the, the primary motivating factors for any organization to embark on a business process management journey or putting together a framework that tackles business process management. Traditionally, there were certain tools and methodologies that we would all use for BPM. So we know the usual suspects of Kaizen, Design for Six Sigma, process reengineering, and all of this revolved around a lot of manual process analysis, identification of the problem areas, and then providing that human oversight and review to determine what the next course of action needs to be in order to drive that standardization, in order to drive that productivity, in order to optimize the quality of output. Now, augmenting this with artificial intelligence makes this a lot easier than it seems. So artificial intelligence offers you advanced analytics, predictive modeling, process automation, real-time monitoring and feedback on your processes, and access to insights. Now, to put this into context, if we have sufficient data being pulled into an AI algorithm or a machine learning algorithm, that model can quickly analyze large quantities of data, identify where the bottlenecks are happening, and even suggest corrective actions if the model has been programmed to do so. And over time, machine learning algorithms will essentially optimize themselves to give you the right course of action or to suggest to you the right courses of action depending on historical performances. That's the power of AI augmentation when it comes to business process management. And of course, at the end of it all, we want to make sure that leadership recognizes how that optimization has taken place, what are the insights that are coming out, and there comes the need of data visualization. Having reams and reams of granular data perhaps does not make sense. It will take way too much time for somebody to understand it. And therefore, AI is now being used to condense all of that data into meaningful insights using technology like natural language generation to write commentaries on what the data insights are. And that's where we utilize artificial intelligence to our advantage as transformation professionals. Rather than doing all of this work manually, we utilize artificial intelligence as a resource. And the output of artificial intelligence becomes an input for us in order to take the next course of action, in order to deliver those insights to the leadership and take decisions based on what the historical performances are. Now, when we speak of data-driven decisions, it's very important to understand what we mean by data-driven decisions. Decisions that are taken on fact, not based on somebody's gut feel, but actually based on fact. That fact has to be supported with meaningful data analysis, has to be interpreted correctly, and supported by correct visualizations in order to determine what the data is actually telling us, and therefore what decisions need to be made. Now, when you look at vast quantities of data, what we essentially look for are patterns that are occurring within the data. And therefore, with recognizing those patterns, we can start predicting outcomes. If that pattern occurs again, what is the outcome that we could possibly expect? And therefore, we can have a predictability equation built that allows us to take corrective action at the right time to prevent process failures. And the decisions based on the data that's coming in is always defined as rules. If this occurs, then do that. This is called a rule-based decisioning. Again, not based on somebody's gut feel, not based on some what what we might just do a hit and trial for a trial and error for, but actually based on rules. If the rule criteria is satisfied, we take a certain decision. If the rule criteria is not satisfied, we take an alternate decision. And this, in fact, is the core competency of artificial intelligence and machine learning. Each one of these, because artificial intelligence can consume vast quantities of data in a ridiculously small period of time. Doing that analysis manually would perhaps take a load of effort, a load of time, which all of us professionals today do not have. We do not have the luxury of time. And that's why we must learn to utilize these tools to our advantage and utilize the outputs to take meaningful decisions based on data. Now, how do we go about implementing artificial intelligence for data-driven decisions? There are a couple of things that we must keep in mind. Number one, what is the problem that we're trying to solve? We must determine what areas in the organization are going to benefit from this. What exactly are we trying to tackle? So, if we're going to go after customer behavior analysis or marketing trends or operational efficiency, each one of them will have a different course of action. Each one of them will utilize either a different algorithm or a set of algorithms, sometimes also referred to as an ensemble algorithm, where you do multiple algorithms in combination for the output desired. So we must keep in mind, what is the business challenge? What is the problem that we're trying to solve? Depending on that challenge that we're trying to address, we must collect the right data, because data is the fuel for all artificial intelligence algorithms. AI or ML, whatever the case might be, data is the fuel. Therefore, the correct data at the correct level, at the correct accuracy is extremely important if we're going to get meaningful insights from that data. Now, I've made a mention over here of garbage in, garbage out. Essentially, what it means is if your data is not relevant, you're not going to get relevant results. Therefore, this is a very important aspect to keep in mind. Moving forward, depending on the type of data, the quality of data, the challenge that we're trying to address, we then make the right choice of the AI tool that we're going to use. To put that into perspective, there are different models, different toolkits that are available as open source that people can leverage from GitHub, from Python libraries, and so on. But making the right selection is very important. If we were to try and utilize a classification algorithm for predictive modeling, it's not going to give you the right results. They are not meant for that kind of job. Therefore, it's very important to select the right tools that we intend to use to solve the problem that we're trying to address. And of course, how do we integrate this with the business process? That is very, very, I would say, closely related to the business challenge. And that's why you'll see that the definitions are very similar, because we need to understand, how does this fit together? How do we integrate the solution with the business challenge? It's very important that the two go hand in hand. Otherwise, again, the solution that you're going to develop is not going to talk to your business challenge, and therefore is not going to give you meaningful results. Therefore, integration with the business process, and I will elaborate a little more on that as we proceed ahead, is extremely, extremely critical. Continuous learning and improvement. As with all of our processes, we're talking about continuous improvement here, and therefore, even the tools, they must continue to evolve over time based on what we have learned in the past, based on historical fact, based on historical data. We should continuously train these AI models to evolve around the evolving business as well. And that is how we make sure that the solution stays alive, the solution evolves, the solution stays relevant. Predictive maintenance. This is perhaps one of the best use cases in business process optimization. Now, as trained professionals on continuous improvement, Lean Six Sigma transformation, one of the things that we always look for, and I've mentioned this previously in one of the slides, is pattern recognition, right? Uh, and how do we develop those patterns? We try to recognize what has happened in the past. Depending on depending on what we see, I think we used to refer to them as leading indicators. If certain indicators are breaching their SLAs, if certain metrics are breaching protocol, there that's an indicator of something that's going to happen downstream. And that is where predictive maintenance comes into play. There are certain steps that need to be followed. Again, some of these I've already mentioned. Acquisition of the right data. If we were to formulate a complete chain of events through our process and identify exactly where bottlenecks occur and why they occur, all of that learning can then be programmed into an AI model, which by analyzing the first step, the input or the influx of volume, would be able to tell you exactly where the bottlenecks are going to occur and possibly what course of action needs to be taken. Once the data acquisition has been completed, we must develop the models, and I spoke about this as well. Model development based on the data that we have, based on the problem that we're trying to address. That's going to be very critical here, because the selected models will then analyze the collected data and give you predictions as to where the process failures will occur, what the failure points are going to be. This is where it integrates with the process design. The process needs to be retweaked, needs to be redesigned based on what the model outputs tell you. I'll give you an example at this point. Now, if we were to have a process of let's say 10 steps, we have a certain volume influx that happens. Based on that overall volume influx, we assign resources throughout the process. However, not every process is completely linear. The requirements of time and effort are going to be different at different stages of the process. Therefore, the resource requirement is also going to change. Now, we could have situations where certain steps in the process are heavy on resources. Certain other process steps are light on resources. But if the pattern of incoming volume was to suddenly change, then wherever we have lesser number of resources aligned, that's going to become a bottleneck. But how much of a bottleneck? How much resource augmentation would need to be required to alleviate the bottleneck in terms of the incoming volume? That is something that an AI model would be able to predict and possibly tell you exactly what level of resourcing needs to be retweaked or what steps need to be retweaked in order to deliver the process outputs at the same required KPIs and SLAs. And we need to continuously monitor how this model functions, how this process is functioning, so that we can feed that information back into our algorithm and optimize it on a continuous basis. This is how we make sure that AI models get well integrated into our processes, well integrated into the day-to-day business as usual, as people call it, and therefore drive operational efficiency. Automated process optimization. There are multiple steps that need to happen before implementing an automated process optimization framework. Now, people will have multiple connotations of what automated process optimization means. Is it simply deploying of RPA? Is it simply utilizing an algorithm? Is it simply building an NLG solution that writes equations for you or writes commentary for you? Is it utilizing generative AI to develop documents for you? It's actually all of the above. It's a combination of all of these elements and how you choose to assimilate that into your processes and therefore optimize it. Leveraging all of these various technologies as and when required in the right sequence, in the right combination is what automated process optimization is. So first, we must select the process and map it out. Unless we understand what the current state is, we cannot get to the future state. We must ensure that our current process is ready for automation. There are certain prerequisites that will need to be taken. The process would need to be standardized to a certain degree before automation can take place. A lot of human-based decisions will have to be converted into rule-based decisions so that they can be programmed into an algorithm, programmed into an RPA solution, programmed into an energy software in order to deliver the output. Tool selection. I've made a mention of this a few times now. We must select the right tool and the right combination of tools that we want to utilize for the identified processes. In one of my articles that I had written several years ago, I made a mention, a small analogy, that a hammer that worked on a steel plate will not have the desired result on a porcelain vase, and it holds true here as well. If you do not utilize the correct tools, the correct algorithms for this, for the problem at hand with the right data set, it's not going to give you the desired results. It's going to be a lot of time and effort, which is wasted. System integration. This is very, very important. You cannot have artificial intelligence algorithms and machine learning algorithms working in a silo. They must be well integrated with the process, consuming the data that comes out at every stage of the process and incorporates that data into its functioning. That's the only way a model is going to be able to understand what is happening with the process and therefore tell you the insights that you're looking for. Monitoring and optimization. Continuous monitoring of the automated process is extremely important. This allows you to tweak the process, tweak the algorithm, tweak the steps that are taking, or even the decisions that have been programmed in order to make sure that the outputs are always optimized. And continuous learning and feedback loops is something that I spoke about in one of the previous slides. This is where it comes in. Ongoing monitoring of how the process is functioning will allow you to make corrective actions, make corrective course actions as and when needed. Preferably, it will have the corrective action built into your model itself. Therefore, being able to predict where the process failure is occurring, but at the same time, also ensuring that you get informed of where the algorithm is not functioning to the desired level or to the optimized level, and therefore what changes need to be made to either the data set that's being collected or the way the data is being analyzed. And of course, employee training and support. We cannot implement a solution without giving sufficient training to our employees who are going to be the users of that system. Whether that's a fully integrated automated system, whether it is standalone algorithms that are used on demand, whatever the case might be, we must provide our employees with enough learning and support so that they understand how the system is to be used, understand how to interpret the outputs of that system, and also understand how to optimize the outputs to their advantage. It's only then that we start fostering a culture of usage of AI and ML, start fostering a culture of continuous improvement, start fostering a culture of innovation. That the last one is extremely important, at least in my mind. Innovation. The most powerful way of getting innovative ideas is to ensure that your employee base is completely tuned in and they understand the importance of it, they understand the power of it. That's where a lot of creative ideas, a lot of innovative ideas on the usage of artificial intelligence and machine learning, at least in my experience, has come. uh, even even in my current organization, we We run campaigns for crowdsourcing. I've been a part of crowdsourcing campaigns in every organization that I've been a part of, and that's where a bulk of the creativity comes from. Not only from the transformation professionals, but employees by and large. They are the ones who are actually on the ground, utilizing these outputs, utilizing the tools that we've given to them, and that's where the creative usage is going to come from. How do we go about, therefore, building a culture of artificial intelligence driven continuous improvement? Certain logical steps here. First and foremost, leadership commitment. Uh, Everything stems from the top down. The leadership must be completely committed to utilizing a technology. They must understand why the technology is being utilized. They must be able to translate that need to their employees further, and therefore that commitment becomes extremely important. If the leadership is not viewed as completely committed to a transformation program, whatever the toolkit might be, the employees aren't going to be tuned in, because they will draw the importance, they will draw the feeling of driving continuous improvement from the leadership support, and that's why this is very, very critical. This is what is going to drive employee engagement. That employee engagement comes from leadership commitment. It comes from the knowledge management, from training, uh, and learning the importance and literacy of artificial intelligence. They must understand the how, the what, and the why of the framework. They must understand these elements in order to be fully engaged. And of course, there are multiple ways of doing this. People can create incentivized programs for participation in the frameworks. There are training workshops that are conducted. There are certifications that are given out. There are multiple ways of making sure that we drive employee engagement. And what's also important is to start small. Start with pilot programs. Learn from what mistakes have been made in those pilot programs, because nobody's going to get it right off the bat. Nobody's going to have a 100% successful model or a 100% successful system right up front. Therefore, conduct your experiments, invest in making sure that you learn, that you do hit and trial, that trial and error process is what is going to allow you uh, to build up to I'm sorry to tweak your strategy to ensure that you have the right toolkit, the usage has been made correct, and that's why uh, pilot projects uh, are always meaningful, because the pilot projects will teach you what mistakes should be avoided, what corrective action needs to be done before you start building out really large scale programs. And uh, if the pilot projects have been designed in the right way, scalability is not going to be a problem, because that's again the power of artificial intelligence. It feeds on data. So if you start small and then start pushing in more and more data into it, it's going to consume it seamlessly. But starting small is extremely important. Moving on to data-driven decisions. And we spoke of this a little while back as well. Converting human decisions into rule-based and data-driven decisions is going to be a very, very important factor. Otherwise, we continue to deal with elements of judgment, as people like to refer to it. There is some amount of judgment involved. There is some amount of human in the loop that will never go away. The final decision should always reside with somebody who has the relevant experience, with somebody who has the right knowledge. However, can AI be utilized as a resource? Can AI augment that human intelligence and take away some of the manual burden? Yes, it can. And that is where data-driven decisions and rule-based decisions are extremely critical. Continuous learning, and I've spoken about this as well. Technologies like artificial intelligence and machine learning are evolving all the time. Some of the mistakes that I've seen people make, some of the mistakes that I've seen my colleagues make, is not keeping in touch with what is being developed. A number of times, while people are studying an algorithm, while people are studying a particular tool, it's already become outdated because something new has come up. And therefore, it's very important to keep in tune with what the technology evolution is in your particular field of interest or in your industry. I've been very closely related to fintechs in my stint in HSBC, and the speed at which fintech solutions evolve, it's extremely mind-boggling. Things that were the the state of the art last week will probably become outdated today. That's the speed at which technology evolves. That's the speed at which these algorithms are evolving. And therefore, it's extremely important for continuously learning what is happening, continuously learning what is being developed by technology, and also keep exploring these technologies, keep experimenting with them on how to leverage them and how to make sure that you choose the right technology at the right time, at the right level. And of course, feedback mechanisms. Made a mention of this as well. Now, once a toolkit has been developed, or once a particular tool has been deployed, is it going to function exactly in the same way all the time? Perhaps not. There are many variables that are in the play. Every process will have multiple variables that affect the overall outcome. And therefore, the continuous monitoring plays a key element here. And feeding that back into the development, feeding that back into how employees are utilizing those outputs is extremely critical. This is how we make sure that our solution stays relevant, stays up to the mark, and continues to get optimized over time and continues to deliver the outputs that we're looking for. Now, in conclusion, I've spoken about a lot of the strengths of artificial intelligence. I've spoken a lot about the importance of understanding how the tools work. I've spoken a lot about uh, how to continuously evolve. But at the end of the day, what do we get out of it? What is it that we look forward to? First and foremost, efficiency, effectiveness, productivity, and therefore cost reduction. This has been part of the key deliverables of every transformation professional, and that's exactly what comes out of utilizing the right technology at the right time. Decisions backed by data. By making sure that we are consuming historical data and tuning our algorithms and tuning our decisions based on the outputs of those algorithms, we will always ensure that our decisions are meaningful. They are not based on gut feel, but actually based on fact. Enhanced customer and employee experiences. The moment we start removing manual effort from our processes, we we will see a better employee engagement because their time and effort is being saved by not having to deal with the manual elements, or at least manual elements to a large degree. Therefore, they are able to spend their time in more meaningful activities and uh, becoming, I would say, trusted advisors to the process. Because based on the outputs of the tools, they'll be able to take meaningful decisions, apply their own judgments, apply their own experiences, and therefore become trusted advisors to the process and not have to deal with the manual data crunching that they used to do in the past. All of this also results in a faster turnaround time of your process outputs, a higher degree of accuracy, and therefore a better customer experience as well. If the customer is able to see outputs coming out almost immediately the moment they fill up an electronic form, and they get the desired output from the process almost immediately, you have a better customer experience. They don't have to wait for the output to come. I'll give you an example. If you were to log into your net banking websites today uh, and requisition for a bank statement, an account statement, you get it almost instantaneously. Is there somebody who's sitting in the back of the website looking at what selections you're making and therefore generating that statement? No, it's completely driven by an algorithm. You make a certain selection, that selection becomes the input for that algorithm, and based on that input, the algorithm fetches all the data from the general ledger, puts together your statement, and delivers it to you instantaneously. That's what customer experience is. Expansion and scalability. I made a mention of this. If our model has been built in the right way, using the right sequence of events, using the right data, and we've conducted enough experimentation and make sure that the model training has been done adequately, regardless of how much data you then feed into it, it's always going to give you that result, and provided you continue to optimize it. But scalability does not remain a challenge anymore. What's required is to ensure that our model has been trained properly, it is consuming the right data, and expansion of the storage is a very simple matter with the today with the cloud service providers. You expand your storage and you pull in as much data as your storage allows, and that allows your process to become scalable to an infinite degree. Lowered risks. Because everything is based on data, based on historical fact, based on rules that have been designed, the overall risks to the process go down significantly. The manual error element comes down drastically. And therefore, risk management becomes a lot easier than it used to be, provided the technology has been implemented in the right way and the tools have been selected in the right way. Creativity and innovation, I spoke of this as well. By creating examples of how the solutions can be utilized, how technology can be leveraged, we can continue to foster creativity in our own employees, and they are the ones who are going to come up with innovative uses for the same technology, maybe replication of the technology into multiple areas, into different dimensions, into multiple use cases that perhaps a transformation professional would not have thought of. And that is where the crowdsourcing comes into play. And it is this creativity and innovation that will drive that continuous improvement on an ongoing basis. And these are just some of the benefits that I have seen personally coming out of these. There could be many, many more, but these are some of the meaningful ones. These are some of the key elements that I felt need to be called out. Now, with that, I thank you for your time today. Thank you for listening to me. I hope this has been of help. Let me assure you, this is just a tip of the iceberg. If you start hunting for more details on how to implement automated process optimization, you'll come up with 1,000 use cases. If you go on to LinkedIn Learning, you'll find resources at your disposal, right from understanding the technology to implementing it to actually building it yourselves. And this is where continuous improvement comes in, even for transformational professionals like us. We continue to improve ourselves over time. We continue to adopt new technologies in the market. We continue to learn what these technologies have to offer and continue to evolve ourselves. Thank you very much for your time today, and I hope this has been of help. Thank you very much.
Thank you so much for the wonderful. Thank you so much for the wonderful presentation, Amit. I mean, it was so insightful. I learned a lot. I'm sure our audience and delegates also, they had a lot to learn. I mean, as you said, it is so important to improve and keep learning. it reminds me of a quote: to improve is to change, to be perfect is to change often. So as you, you also stressed on continuous learning. So I mean, recently Singapore government, they announced a subsidy program. I mean, where they're encouraging people above 40 to go to the colleges and learn AI models. So this is how it is supposed to be. I would request our audience to post their question in the Q&A section. We already have a few questions. So the first question is, with abundance of data nowadays, there is a lot to plan or in funnel to execute. How do we finalize which sample would be feasible to execute?
Again, this is a very generic question. I'll try my best to answer. There's a lot of data available. That is correct. Absolutely. Today, there is a wealth of data available. Quite often, there is a wealth of data available on open source. The key element here is to make sure that that you're selecting the right data elements. Make sure that the data that you're collecting or the data that you intend to use is relevant to the process that you're tasked with changing. Keeping an underlying eye on the problem that you're trying to solve. That's very, very important. And I say this in every training session that I conduct, that always keep your eye on the problem that you're trying to solve. If you understand the intent, if you keep focused on the intent, the content will follow on its own. So understand the challenge that you're faced with, understand the problem that you're trying to solve, and then decide what are the data elements that are relevant to that problem and therefore will have a desired effect if analyzed in the right way. But keep in mind that there will always be some amount of trial and error. Sometimes you might end up collecting data elements that may not be right. And it is that trial and error, it is that experimentation which will allow you to make better decisions.
Yeah, rightly said. I mean, you also stressed about the pilot project that we do as a prototyping before launching it in the real world, so that there is, I mean, distinct division, what is ideal and what is real. So, I mean, the thing that you mentioned about trial and error. So, there can be anomalies when we launch in after the pilot project also. So how do we change our course of action? Because when we see the consumer, when we study the consumer behavior, their mindset, it is prone to change because I mean, because of the ever-changing situations and mentalities, it is prone to change. So how do we move forward in those cases?
So let me try and explain this with a real-world example of how an AI model can be utilized. You made a mention of customer behavior, right? So let's concentrate on one angle of that. Let's say we have a customer help desk. We are dealing with incoming queries, right? And usually what would happen, and just for the sake of argument, right now, let's concentrate on emails that are received in the help desk. Our usual course of action would be read the email, try and understand what the customer is looking for and respond. Now, a lot of times what people do not keep into account is the tonality of the email. And therefore, we end up giving canned responses to the customer. We will look for a certain payment due or invoice number or certain keywords, right? And just pick up those details from the system, respond in a very, very robotic, canned manner, not keeping into account the tonality of the email. Today, people are utilizing AI algorithms for sentiment analysis. Okay. There are multiple different algorithms which are available, which will read the email, read the text of the email, and give it a sentiment score. A sentiment score which is ranging from -1 to +1. +1 means a very, very happy customer. A -1 means a very, very dissatisfied customer. Therefore, the tonality of the response needs to be tweaked according to the manner in which somebody has written that email. And today, people are actually leveraging these AI algorithms to understand the tonality, to understand the pain of the customer, and therefore they're able to use generative AI to generate an email response with the right tonality again. That is how we continue to evolve this. That's how we ensure that changing customer behavior has been factored in, and it is not just customer is asking for XYZ. No, understanding the way the customer is asking for that information is also important, and that is how we make sure that customer behavior has been put into the equation. I hope that answered your question.
Yes, certainly. I mean, the learning curve is endless. We have again a few questions lined up. I'll direct those to you. So we have a question from Zankana. We generally look at maturity of organization when we look at certifications such as ISO, Lean, Six Sigma implementation. When do we say that organization is AI ready and ensure that organization is not using AI as a fad?
That's a difficult question to answer. There is no right or wrong answer for this. Okay. In the classical continuous improvement frameworks, we used to utilize Lean to clean up the low-hanging problems, and then utilize Six Sigma to drive the quality framework, to drive the change in the outputs. Today, the world has changed drastically. We in the past we used to have a problem with data, right? There used to be a lot of manual data collection, and therefore we had all these manual activities of lean events and problem-solving workshops and so on. Today, most of the organizations have gone past manual data collection, and we are getting system-generated data, right? If you have an abundance of data, you are AI ready. That's the way I would look at it. Even if manual data collection has moved to a point where majority of the data is available to you on an on-demand manner, you're able to extract the data whenever you need it, to whatever quantity that you need it. Because like I mentioned, the fuel for AI, ML, NLG, all of these algorithms, all of these tools is data. If you have enough data, you are AI ready. The thing to keep in mind is applying it in the right way. I personally would still apply Lean first, because not everything needs an AI solution. Not everything needs an automated robot to conduct the process. So use Lean to clean up the manual efforts in the process. Use a combination of Lean Six Sigma to tackle some of the very obvious problems that you're going to have, and use artificial intelligence for more advanced problem solving. That's the sequence that I would go into. But wherever an organization has an abundance of data available, they are AI ready. That's the way I would look at it.
Certainly. I think there is another follow-up question from Zankana again. I think you answered it with your points right now. So he's saying that there are too many softwares available, low code, no code software. Then on the other hand, there are people who use Python, TensorFlow, etc. If someone is a novice to AI, then where does one start, or which path should one take, like the one listed in Six Sigma or DMAIC?
So, like I mentioned, Six Sigma DMAIC has a certain relevance. It will help you to understand what problem solving is, and that is, like I said, part of the learning mechanism, right? Understanding problem solving is the first step towards building a continuous improvement program. So start with DMake, understand how to logically go about solving problems, because even within DMake, in the analyze phase, there are certain elements that you will utilize for statistical data analysis. That is what DMake resides on. That the DMake is actually a very powerful methodology. I've spent the bulk of my initial years in learning DMake, in teaching people DMake, and in the analyze phase, we take data-driven decisions. We do data-driven problem solving in the Six Sigma cycle of DMake. That will give you the first exposure to the type of statistical models that are utilized. You can then progress on to expanding those statistical models into AI and machine learning models, because at the base of it, it still remains very, very similar. You will still utilize regression models for predictive modeling. You will still use classification models for discrete data analysis, and AI will just augment this. But for a novice, start with DMake, build that knowledge base, understand what problem solving means, understand how to utilize these statistical data analysis models, and then progress on to artificial intelligence.
Certainly, I hope that answered your queries, Ankana. We are already over time, so in the interest of time, we'll just take one final question. There is a question from Jaya. Can you give some example of AI use cases in manufacturing operations?
The one that stands out for me is predictive maintenance. In a manufacturing operation, you will have a series of machines that are being used for the manufacturing process. If we utilize the data coming from, and each one of these machines is going to have a bulk of sensors built into them. Okay, each sensor is feeding data back into your database on an ongoing basis. How many units have been produced? Which parts of the machinery are running at an optimized level? Is the RPM of a certain motor running at the same level that it's supposed to, or are the RPMs dropping? All of these data points coming in is going to help you to build a predictive maintenance algorithm, because basis all the data that's being fed through these sensors, you can build the pattern. If a certain motor is not running optimally, what are the downstream effects that can occur? Will that create a bottleneck in one of the downstream process steps? And therefore, what corrective action needs to be taken now? Historically, if a certain machine has resulted in a complete breakdown, depending on certain leading indicators, if those leading indicators start occurring again, the algorithm will be able to flag to you that a certain part of the machinery requires maintenance right now, otherwise it is going to collapse 2 days later. So predictive maintenance, in my view, in manufacturing is one of the strongest use cases.
Thank you so much, Amit. We had a lot to learn from you, and I'm sure there will be many more questions. Audience, please feel free to send us those questions. We'll send them to Amit, and you can also send a connection request to Amit on LinkedIn. Amit, it was a wonderful session. We look forward to many more associations like this in future too.
Thank you very much, Peter. It was my pleasure to be here. And like I mentioned, I hope I've been able to put some more insight for people on what AI ML is, how do we utilize it for transformation, and I hope this has been of help. Thank you very much.
Thank you again. So we have our next session in 10 minutes. See you all in 10 minutes at 10 a.m.